Yeah, good afternoon guys. It's back again, KIWA Electronics. So let's just go. So I'm designing a H bridge for my three-phase inverter. This actually, it's a wide project. It's a very wild, not wide, where I'm basically doing what it's done, but doing it my way, and actually experimenting so that I can see if we can make something more efficient. So this is a three-phase inverter, the H bridge section. Okay, this is a single phase first of all, and it's the H bridge section. Here we can add from about 40, let's say about 80 volts to 400 volts DC, and here we'll get an AC output of 240 depending on the control code given to the H bridge, the frequency and whatnot. So this is the SV section, the feedback, where I'm using an Arduino Pico. So here's the phases, and here it's the voltage slash current sensor, the SV, which goes back to the Arduino, which tells it how much current and how much voltage we have. Let me just connect these and see if I've got any other connection. Yeah, none. So the purpose of this video, we're gonna just create, okay, let me refresh it. We are gonna create we are gonna create I don't know why we have got this number 1. Is there any way we have got Q1? We don't have Q1 anywhere, and it's popping up. Anyway, we're just gonna remove it. And what's Q1 connected to? Q2. It's connected to Q2. So I guess here in Q2, oh yeah, in Q2 we have got Q1. Yeah, so that's that. I do not mind mostly about the values, the 4.7K and the 10K. These are actually gonna be valid via what we want. So let me first of all remove this Q1. Will be varied according to anything. So I'm gonna space to rotate. Let me do it quickly here. Yeah, so basically it's all about aligning. That I know will actually let them stay there. And let me get these two. these are the outputs. Yeah, I guess it's enough. So let me just render it at the 3D and see. I would say basically that's something good. So now one thing about these boards is that let me just complete one board and then I'm gonna copy paste it to the other board. So on the high voltage I'm gonna use the bottom layer, and let's come here, customize, go with 15, will 15, diameter, let's do 30. Okay, let's do 50. 80. Yeah, I guess 80 is good. Let's do the yeah, that's the cool stuff. Basically don't want these components to get touched with the close to the, because yeah, it's gonna pass a lot of current. So and then you can see I'm using the P ground because I don't want the ground to be the same, most to be practically the same, because these are gonna be 3 on 3, and I want a neutral, so I don't want the feedback to go back. As I say, this is actually Q3. Q3. So on the Q3 we can go to the top layer. Yeah, I'm gonna use a jumper. Okay, so okay, yeah, that's it. So let's go back to the let me do 10. Now we'll just connect the let me just do 35 mm. Just remove those. Yeah, that's more like it. go to the top layer and this. Go to the bottom, or like I basically like to do things. So one might say this like is amateurish work. Yes. Amateurish work. Oh yeah, it's still connected. Okay, so let me just refresh the 3D form. And then don't ask, I haven't added the borders because I've got some work to do. Yeah, so this is the output here. So you can see this hole is for the jumper. Can't I push? Yeah, let me just push it here. Yeah. That's the 3D form. The 2D, let's the 3D here. That's nice, that's nice. Yeah, so I basically love the EasyEDA than the KiCad. EasyEDA is actually, sorry, the EasyEDA is actually very fast for me and very efficient. Yeah, I love it. So let's go back to this. Excuse me. So I need a connector for the ground. And the AC out. I'm looking for an AC connector, but I don't know which exact. I could use this. Yeah, this will do. Say high current. Will I get any Shift F to open? To open the browser. Let's see if they have. Basically I want images because I don't know exactly. Or let me just come here. DC power connector. Oh, just the normal one. HDMI accessory, board to board connector, DC jack SIM, jumper. PCIe, board to board. Auxiliary, peg spline, pogo. House connector. wire to board. By the way, what about the hole? Exactly. Just use that. Control C. And then D. So the ground. You can actually go. So it's the VCC. GND. It's the neutral. And that's the live. So one thing about here is the inductor. Let me just type first. What inductor should I use on the AC output after the H bridge? Capacity and value. One thing about this, you should give it a prompt to give you short answers. 0.2 millihenry. Is it 2 microhenries or millihenries? Shift F, Control V. 2 millihenries. So in this, let me just go to inductors and transformers. Where is it? Inductors and transformers. Should open this. Open here. Inductors, it has got SMDs. Power inductors. One thing I hate is making through-hole projects with SMD components. Is actually very tiring. When it comes to like project, when it comes to the full, like you have got the project, now it's ready, and then now poof, you have got through holes and SMDs at the same time. It's very tiring. Or I can just use current sensor pulse transformer. Adjustable. They're telling me about this, and I only need something close to this. And these things do basically generate a lot of some heat. So let me just put this under consideration. Let's get to the browser, and then to let's see. SMD through hole. Let's come here and see. Choke core. Will this help me? It will give me none. Because I need this filter. I think so. What I'll do is just use this. Let's go a bit and see. $17 mm, that's something big. Let's go to 15. Come here. Before I place anything, I just wanna see the view first. Let me just see the 3D. Yeah. So don't wonder that I'm using very big, because I might reinforce this a bit. That is the VCC, should go there. The AC and oh, this is the ground. It is the possible thing to the ground here. Just move it to this line, and this one also to this line. The U2, what was the U2? It's connected to pin 1 of this. That should go there. 20. So 100. That is for the ground. So if I come on the 3D, so this is the DC, and this is the AC section over here, DC, AC. So one thing I'm gonna add is just the filter here. Let's go back to the PC, to the schematics, and remove this, Shift F. The best thing about EasyEDA is that you are searching things online, like they are just there. get real-time updates, models, everything. So I'm putting this as a candidate. Let's just place it there, and then let's go back and look for more. Yeah, and if you do like this content, hit the like, subscribe to this channel. It helps me and keeps me motivated to do more and more of this. Okay, yes, we are gonna stick with that and remove this. Oh no, we were removing the wire. Yeah, let's go get back here. We're gonna remove this. What's the shortcut of this? Alt L. Is it Alt 1? Okay, let's just keep with what we have applied. Do that. Yes, it will come. It will come. Just remove these and that. Let us rotate this. Yeah, so yeah, so it's there. So let me see if I can do the top layer. No. Yeah, so basically this is a H bridge section where you can add E, is it called an EGS 200, Arduino Nano, Arduino Mega, Pico, ESP, whatever. So this is a single phase right here. This is a single phase. Now I need 3 phase, so I need to create 3 more. Yeah, okay, so let's go to the sizing. I need it to be like over there. Yeah. Give me some space. Let's add let's add 2 margins, and then I need a copper layer. Over there, then to make sure it has got ground. Let's come back here to the margins. Yes, I might call it amateur moves, but so let me just build. Yeah, so that is basically isolated. Let me go to the bottom part. Go to the bottom, then do it the same. Also, you can basically, you can just only do the bottom. Yeah, so on this, okay, let's go to the PCB, and then here. Yeah, so you can see this is connected to the ground. And I wanted it to be that way. Can I go to 3 to 260? Then one hole there. Another one there. Okay, and another one there. You will go up a little bit. So yes, I'm gonna just drill holes for the heatsink. By the way, don't I have also all of these are on the top. That's okay. Yeah, so just gonna copy. Before I deselect, let me just look at the dimensions. You move over there. Also move down. Let me just see how it looks. No, on the 3D. Yeah, that looks weird. Because I was thinking this should have a heat sink on this side and this heat sink on this side, so let us just delete it. That is there, and then We add one more. Control V. This I'm just gonna I don't have a mouse, I'm using my buttons. So if you want this project, just comment, subscribe, and then I'll send it to you. Just come over there. Just confirm on the edges. That is good. Yeah. Once I guess it's locked to the. Oh no. Yeah. So you basically rebuild. Mm-hmm. Okay, let me just. Yeah, so this is the board This will be phase 1, phase 2 and phase 3, and then just join these, the neutral, all of them together, and then you'll get each phase will get 3 phase. So this inverter is a collection of my knowledge through what I've learned by repairing day inverters, UL Max inverters, and basically they are not actually 3 phase. It's actually a single full inverter which is copied 3 times. Thus you get it is a 3 phase, but it doesn't function like a 3 phase. How a 3 phase should work. So what else? So another thing about this, you can also use it as a low frequency 3 phase inverter, or as a high frequency 3 phase inverter. It will all depend on how you want it. So using the EGP, or using the EGS 002, you can use the functionality. And also there's another board which has got a 3 phase mode, and it also works the same as this, but that I thought it has got I'll see it has got fewer gate drivers, so I don't know if it's the single mode or. And also you can also use this as a half bridge mode, where you can get one phase is 250 divided by 2, that is approximately 75 volts, and the other phase is 75 volts. You get 250 volts. Yeah, so another thing you can see, I'm using very, very complex MOSFETs, IGBTs to be precise. So you can basically do what you want. Add small 44 ends, T15, T14s. It all depends on what you want to use. So for this, I've basically made a 10 kilowatt 3 phases inverter. So this is 10 kilowatt. So this is 30 kilowatt inverter. It's a basic form, so don't get it twisted. So one thing I'm gonna add is, as you can see, you don't have some IGBT, some capacitors, filter capacitors, which run through the half bridges. We don't have it here, but that basically is for filtering. I said H, not full. Yeah, basically most of the things you get in the internet are not quite accurate, and you should basically I think someone. Let me see if I can find so this is a guy who's creating inverters. Yeah. So as you can see here, this is a H bridge. It drives in 400 volts and extort to 40 volts. So as you can see, it's using filter capacitors, filter section. This is what I was doing. So he's using a dual choke, but what I'm concerned is with here. As you can see, he's using 3.3011 kV, 1 kV, and 5. Is it 560? Yeah, 560 R resistor, and then a diode over here. Yeah, so you can see he's using EG810. Basically, he's just taken the routing from the board I showed you and then replicate it here. It's not bad, actually it's very good. It helps one can we see it over here? Yeah, so you can see on the data 24, I don't know what he has written. Okay, 50R 26. Yeah, so as you can see, he's using some capacitors over here. Let's just go and see if we can add so this is a basic form, and you just add things to make it better. So let's go in the capacitor section. So we need the through hole. then we search. One KVA 104. Yeah, and if we come here and Google, so you see is using this. So these are just 1.5, 1440. Yeah, so you can see him is using a different set of resistors. 22, 6.8. We have used 4.7. He's using 5.1 and 22 whereby I'm using so yeah, let me just place Control Shift F. Let me look for the capacitor. So let's just add this. I don't know why it's becoming like that, and F. Let's look for the through hole ceramic capacitors. Go to the voltage 1K and then apply. Yeah, so we are basically getting this, but I was wanting the rectangle one. Yeah, so let us just pick any. So here we get that, and then that. Okay, let us just bring that there. Then we get a diode. So I guess the diode is the same as the 41, 48. Yeah, because we need let's see the characters of 41. 1 and 41, 48. Sorry, 1 and 41, 48. 100 volts. Okay, let us remove the 1 and put the 4. So let's go to 700 volts diode. Common diodes with the highest capacity. And I saw on the 10K we need approximately 47 amps. Yeah, so choosing a suitable component to your project is actually crucial for the durability of the project. For me, this will work, but will only drive let's say a maximum of 3 kilowatt motor, 3 kilowatt of consumption. But if I go higher, it will start some issues. Yeah, we need something with that peak, 40 to 60 amps. And some diodes here I'm seeing haven't. Oh yeah. Common of 1 amp. Okay, sorry. So let's look up some characters about this. Hey. Okay, let's just use what we have, because I don't think that we need 4. I don't think we need 60-watt diode. Yeah, so this, yeah, peak of 30. That's nice. That's very nice. me just let me just use the reference from there. Yes, all of them are looking down, but then one thing I can see, his MOSFET, the MOSFET here does not have something we call does not have a diode inside. As you can see, it's just one. Or else let me look at mine, and all of them are shooting up. And his are going down. So that's something to consider. That's why I'm saying that you should take note of what you are really doing into the application. So one thing that I can change is this diode to this, the 4148 to 4007. Just that. So yeah, so here what I can just add is this ceramic capacitor to connect with that. Basically do is just take this and just place it there. And then there. So this is basically it's called I'm just basically breaking the rules. It will work, but it will have a lot of less efficiency, but this is let me say it's something. So what I can do is just let me just pause for a minute. I'll be back. Where do I pause? Just gaze upon that. Okay, so we are back. We are back. I don't know if you are hearing me. Okay, sorry. Yeah, so as you can see, I had to dismantle that so that I can add the capacitors. Yeah, so basically it's not coming, but it will be rugged. You can just place the capacitors, like you burn them this side and this side. Basically this is a test board. Then another thing, you can just make this on the breadboard and see how it goes, or just a through hole breadboard. Just take a screenshot of that. Yeah, so that's it on okay, let me just add my logo. Files, import image. That wasn't it. Yeah, so that is that. Thank you for watching. Okay, and that's the weirdest thing I've ever done, but practically the greatest. 3 on 3, because once what made me take this project is that most of the inverters you see here are not quite 3-phase. They actually single phases, because actually I can put high and low here, high and low here, high and low here at the same degrees. Let's say at 120 degrees phase shift, all of them will work, but the output will be separate. Also, I can link these, I can connect all the parallel all the outputs, of which will also work, but the moment I shift a single phase, it will actually explode. The IGBTs will actually explode. So it will be something something remarkable to do. Yeah, and then the heat sinks here. Yeah, so thanks for watching. It's been 2 hours of doing what I do. Give a like to KIWA Electronics. Bye.